So let's start with the second part of the machine learning. Now here we are going to discuss the types of learning. Now broadly speaking, machine learning algorithms are of three types: supervised learning, unsupervised learning and reinforcement learning. Now these supervised learning are also known as inductive learning, given training data plus desired output. That means the labels are there. Labels means that you have got some idea about the inputs and also about the outputs. Then unsupervised learning is given training data without knowing the output. So you have absolutely no clue about what kind of output can be there. Then semi-supervised learning is, which is again a new factor which is added, that is given training data plus few desired results. You may not have complete idea, but you have some very vague idea, and that is categorized as a semi-supervised learning. And then the last one is reinforcement learning, where the reward from sequence of actions is the basis on which this learning takes place. Now let's understand unsupervised learning is a kind of data mining. The data mining task is performed by inferring a function from labeled training data. The training of data consists of a set of training examples. So you know some examples, you have some idea about your data, and then you can develop an algorithm which can be used for the purpose of getting the expected results. In supervised learning, each example is a pair consisting of an input object, typically a vector, and the desired output value known as supervisory signal. Now, a supervised learning algorithm analyzes the training data and produces an inferred function which can be used for mapping new examples. An optimal scenario will allow all the algorithms to correctly determine the class labels for unseen instances. This requires a learning algorithm to generalize from the training data to unseen situation in a reasonable way. So you have some idea, and that is why your algorithm which is developed definitely will help you to getting the unseen, which we don't know, but still you can apply that and you may get some result which is expected on expected lines. Supervised learning algorithms, there are various applications which are there and various areas where you can apply that, and some of the classic examples are like linear regression, logistic regression, decision trees, support vector machines, k nearest neighbors, naive Bayes, random forest, polynomial regression, support vector machine for regression. All these we will be discussing also, and will be working also on that. Now these two types of learnings that we have seen are supervised and unsupervised learning. There is another type of learning that is a blend of both, an approach called semi-supervised learning. Now, semi-supervised learning algorithms are trained on a combination of labeled and unlabeled data. As we have already discussed about labeled and unlabeled data, it's a combination of the two. And this is useful for a few reasons. Because in some situations, it happens that you have some idea about the data, but not very clear idea. So that is why it's a mix of both labeled and unlabeled data. Now first, the process of labeling massive amounts of data for supervised learning is often prohibitively time consuming and expensive. What's more, too much labeling can impose human biases on the model. That means including a lot of unlabeled data during the training process actually tends to improve the accuracy of the final model, while reducing the time and cost spent building it. So that is why semi-supervised learning is also applicable, but in most of the cases you will see it will be either supervised or unsupervised learning. For that reason, semi-supervised learning is a win-win for use cases like web pages. Now in some cases this may be very helpful, like web page classification, speech recognition, or even for genetic sequencing. In all of these cases, data scientists can access large volumes of unlabeled data, but the process of actually assigning supervision information to all of it would be a tough task. So that is where semi-supervised application is slightly difficult. Using classification as an example, let's compare how these three approaches work in practice. Now, supervised classification, the algorithm learns to assign labels to types of web pages based on the labels that were inputted by a human during the training process. So when you are training the computer, you are inputting certain data, and that data becomes the basis for computers to learn, and then when you go for testing, it will be tested based on that training data that you have used for in the process of training. Unsupervised learning, the algorithm looks at inherent similarities between web pages to place into different groups. Semi-supervised classification, where labeled data is used to help identify that there are specific groups of web pages, types present in the data, and what they might be. The algorithm is then trained on unlabeled data to define the boundaries of those web pages, web page types, and may even identify new types of web pages that were unspecified in the existing human inputted labels. Reinforcement learning is an important type of machine learning, and where an agent learns how to behave in an environment by performing actions and seeing the results. It allows machines and software agents to automatically determine the ideal behavior within a specified context in order to maximize its performance. Simple reward feedback is required for the agent to learn its behavior. This is known as the reinforcement signal, because unless the agent starts learning the way you want, you will keep on trying. So that is what you are seeing. The master is trying to train a dog, which is in this case is an agent, and the environment is, of course, it's an open environment, and you try and give it instruction and it follows, then it's fine. If it doesn't follow, then again you try and use some method. So it keeps on repeating. So that action, and then there is a reward. In case it does it, then there is a reward. If it doesn't do, then you may punish him. That is how the process goes on. Reinforcement learning allows the machine or software agent to learn its behavior based on feedback from the environment. This behavior can be learned once and for all, or keep on adapting as time goes by. If the problem is modeled with care, some reinforcement learning algorithms can converge to the global optimum. This is the ideal behavior that maximizes the reward, and that is why this process is a repetitive one, and the agent keeps on learning, because you will see that every time you teach something, the response or the agent is definitely going to perform better and better. So that is how the entire exercise goes on. Now, some of the applications of machine learning mentioned below are image processing, that of course is very commonly being used now. Robotics, again quite commonly being used. Data mining, video games, text analysis, fraud detection, healthcare. So this completes the second part of the machine learning. Thank you.